A whopping 3.8 billion years ago, when Earth was still getting bombarded by massive space rocks, the first living beings emerged. Despite this chaotic planet lifestyle, life hung in there, refusing to bow down. Throughout the epic saga of Earth, it has weathered all sorts of events like explosions, colossal asteroids crashing in, gigantic volcanic eruptions, and abrupt climate makeovers. These catastrophic moments have wiped out countless life forms, and on some occasions, almost hit the reset button on Earth's species. Yet, life endures, showcasing an inspiring resilience in the face of adversity. Have you wondered what it takes to wipe out all life on Earth? Surprisingly, even though humanity seems delicate, sterilizing an entire planet is no walk in the park. Nevertheless, there are few catastrophic scenarios that could bring about the permanent demise of all life on our planet. 66 million years ago, a colossal asteroid, comparable to the size of a city, slammed into the Gulf of Mexico. They were dinosaurs, and countless of species on Earth during that era. Back then, our human ancestors were still in the evolutionary pipeline, but this impact turned out to be the pivotal moment in our history. Had it not occurred, dinosaurs might have continued their reign, keeping us mammals in perpetual shadow dwelling, never to emerge into the spotlight of the Earth. Humans aren't always in control when it comes to unpredictable events. There's a chance that, in the future, an asteroid might bring about the demise of every person on Earth. Thankfully, such a catastrophic event is not anticipated in the near future. According to NASA, Earth experiences a significant asteroid impact approximately once every 100 million years, as indicated by the geological history of planet collisions. However, it's worth noting that smaller asteroid impacts occur more frequently. In fact, there's evidence suggesting that within the last few thousand years, some individuals may have lost their lives due to impacts from small natural objects from the space. What are the odds of our planet experiencing a catastrophic asteroid impact capable of eradicating all life? According to simulations presented in a 2017 Nature publication, the scenario requires an enormous space rock, one colossal enough to evaporate Earth's oceans. Only celestial bodies on the scale of Pallas and Vesta, the largest in our solar system, possess the potential for such devastation. The notion harks back to the early days of Earth, where signs suggest a significant collision with a planetoid named Theia. However, the likelihood of such colossal collisions occurring in our present era is exceedingly low. Around 2.5 billion years in the past, a momentous event known as the Great Oxidation Event unfolded, bestowing upon us the life-sustaining air we now enjoy. This transformative episode featured the emergence of cyanobacteria, often referred to as blue-green algae, which flooded our atmosphere with oxygen. This atmospheric makeover paved the way for the establishment of multicellular life forms and, eventually, set the stage for the existence of beings like humans, who could thrive in an oxygen-enriched world. About 450 million years ago, Earth experienced a significant event known as the Late Ordovician Mass Extinction, marking one of the planet's profound periods of biodiversity decline. This intriguing episode was triggered by a unique phenomenon, a substantial and prolonged decrease in the levels of oxygen across the globe. It's like a time when the very air sustaining life underwent a mysterious and protracted transformation lasting for millions of years. What might have triggered such an extraordinary occurrence? Back in the ancient period, Earth's continents were like a colossal puzzle piece, fitting together in a mega landmass known as Gondwana. At that time, the majority of life was still thriving in the oceans, although some brave plants were just beginning to venture onto the untamed landscapes. Then, as the era neared its end, a dramatic climate transformation unfolded, draping the vast supercontinent in massive sheets of ice. This profound global cooling wave event acted as a chilling curtain, initiating a series of events that led to the decline and extinction of various species. However, a second wave of the extinction event surged, when oxygen levels took a nosedive. Scientists have uncovered signs of this transformation in samples collected from the ocean floor worldwide. Some experts propose that River of Ice played a pivotal role in reshaping the ocean layers, each with its distinct temperatures and specific concentrations of elements like oxygen. Nevertheless, the precise reason behind the decline in oxygen remains a topic of ongoing discussion among researchers. For reasons yet to be fully understood, over 80% of life on Earth perished in the late Ordovician mass extinction, as estimated by some studies. The intriguing question arises: could a similar depletion of oxygen, a deoxygenation event, occur once more? Drawing a chilling parallel to our present circumstances, scientists involved in a recent study published in Nature Communications suggest that contemporary climate change is already diminishing oxygen levels in our oceans. This ominous trend has the potential to jeopardize marine species, echoing the catastrophic events of the past. During the late Ordovician period, many astronomers over the years have speculated that the instigator might be none other than a gamma-ray burst GRB. They are enigmatic occurrences, appearing to be the most forceful and energetic explosions in the vast planet. Scientists suspect these events may be connected to exceptionally powerful explosion. However, and fortunately for us, we have yet to witness a burst occurring close enough to Earth to comprehensively grasp the intricate dynamics at play. Up until now, these mesmerizing GRBs have only been observed in distant galaxies, leaving us yearning to unravel the mysteries they hold. A scenario unfolded within the vast expanse of the Milky Way, a universe event with the potential to reshape life on Earth. While such incidents may have occurred in the distant past, the repercussions could be nothing short of catastrophic. Imagine a burst of gamma-ray radiation directed towards our planet, lasting a mere 10 seconds. In that brief span, the aftermath could be profound, eradicating at least half of Earth's protective ozone layer. It's a force that, despite its brevity, holds the power to unravel the delicate fabric of our atmosphere. Ozone, a crucial component of Earth's natural sunscreen, would bear the brunt of this celestial onslaught. In the wake of this short-lived revolution, even a modest reduction in ozone could set in motion a chain of events with far-reaching consequences. Reflecting on recent human knowledge, we've come to understand that even a minor depletion of the ozone layer can trigger significant challenges. The depletion, similar to removing a vital layer of protection, exposes our planet to the harsh elements of the planet. The repercussions of such a universe event extend beyond the atmospheric realm, sending shockwaves through the intricate pattern of life on Earth. Ecosystems that rely on the delicate equilibrium of nature would face unprecedented disruptions. The devastation would cascade through food chains, resulting in the mass extinction of numerous species. In essence, the potential consequences are burst impacting Earth is not confined to the fleeting moments of its occurrence. Rather, they unfold as a narrative of ecological upheaval, where even a brief celestial event can leave an enduring mark on the intricate way of life on our planet. A powerful world event by scientists has the potential to wreak havoc on the delicate balance of life in the upper layers of our oceans. These regions are presently bustling with life forms that play a crucial role in producing substantial amounts of the oxygen we breathe. Interestingly, unleashing during such an event possess the ability to dismantle the molecules of atmospheric oxygen and nitrogen. Intriguingly, these interactions lead to the transformation of atmospheric gases into nitrogen dioxide. This compound, more commonly recognized as the air pollution hangs heavily over highly polluted cities, has the capacity to shroud the Earth. There was a thick layer of the sun enveloping our planet. This isn't just about urban smoke. It's about a global phenomenon. The consequence? A space dimming as sunlight struggles to pierce through, setting in motion a planetary cool-down atmosphere similar to a worldwide ice age. While these scenarios are undoubtedly horrific for life as we know it, they pale in comparison to the slow but inevitable fate awaiting Earth in roughly 1 billion years. According to a recent study featured in the March issue of Nature Geoscience NG, The majority of life on our beloved planet is destined to perish due to a shortage of oxygen. It's a fate that, despite its distant timeline, adds a poignant layer to the ongoing narrative of our planet's destiny. Scientists propose an intriguing idea that challenges our perception of Earth's enduring characteristics. They suggest that the abundant oxygen we currently enjoy in our atmosphere might not be a permanent fixture of our planet. Instead, they predict a universe timeline shift, foreseeing 1 billion years into the future when heightened solar activity could send atmospheric oxygen on a downward spiral, returning it to pre-great oxidation event levels. To unravel this mystery, the researchers embarked on a journey into the realms of climate models and biogeochemistry. By melding these sophisticated models, they embarked on a virtual expedition through time, simulating the unfolding drama of our atmosphere as the aging sun, like a celestial maestro, orchestrates a symphony of energy output. The outcome? A captivating narrative that unveils the potential retreat and flow of Earth's life-enabling oxygen, adding a thrilling chapter to the epic tale of our planet's evolution. Scientists have discovered that over time, Earth reaches a critical juncture where the levels of atmospheric carbon dioxide undergo a breakdown. When this occurs, the very plants and organisms responsible for generating oxygen through photosynthesis begin to dwindle. As a consequence, our planet faces a perilous situation where the diverse array of life forms necessary to sustain the oxygen-rich atmosphere vital for humans and other animals becomes insufficient. In essence, the delicate balance that supports the breathable air we depend on is disrupted, posing a threat to the ecological harmony of our world. Pinpointing the exact onset and duration of this deoxygenation process, which might unfold in as little as 10,000 years, hinges on a multitude of complex factors. The inevitability of this cataclysmic event looms large, according to researchers, leaving a finite window for supporting the diverse life forms we know today. Yet, amidst this sobering revelation, there is a glimmer of hope. Humanity is afforded the luxury of an additional 1 billion years to ponder and devise alternative plans. The clock is ticking, urging us to explore sustainable solutions and adapt to the evolving needs of our precious planetary home. Earth has a tipping point where the balance of atmospheric carbon dioxide is disrupted. This disruption marks the beginning of a chain reaction that leads to the demise of oxygen-producing plants and organisms dependent on photosynthesis. As a consequence, the vibrant pattern of life sustaining our oxygen-rich atmosphere are crucial for humans and other animals. How do you think life on Earth will come to an end? Let us know your thoughts in the comments below.